Okay, I just wanted to create a short video to explain, if you're interested, um, why the title of this module is Single Variable Linear Equations. Well, the single variable part should be pretty obvious. Single variable meaning one variable. Linear, I'll explain that briefly. I try not to go into too much detail. Here's an example of a single variable linear equation. Wow. Yes, you will be able to solve an equation like that um, by the time you finish this module. You better be able to. Anyway, you might think, well, wait a minute, that's not a single variable linear equation. That's a one, two, three variables in that equation. Well, what makes it single variable is there's there aren't two different variables in the equation. There's only one. X is the only variable in the equation. It may appear three different places, but it's the only variable in the equation is x. There's only one variable in the equation, that's x. So that's why it's called a single variable. Now, why linear? Well, linear is a classification, an algebraic classification of expressions. Remember, I have two expressions here. I have the expression 3 times the quantity 5x minus 9 on the left of the equation, and I have the expression negative 2 times the quantity 6 minus 2x plus 6 on the right side of the equation. Remember, an equation is two expressions set equal to each other. Linear is a classification, an algebraic classification of an expression. And yes, it does have something to do with the word line, but I'm not going to get into that right now. Um, you'll understand that in the next module. For now, I'm just going to explain very briefly the classification of linear. But I have to start that explanation with constant. We know that a constant is something that doesn't have a variable. It doesn't change. It's always the same. So an example of a constant expression would be like maybe 15. Or we can make it more complicated, like pi minus 1. Or 3 times the square root of 7. 3 times the square root of 7 plus 2. Or as simple again, 0.57. These are all constant expressions because they don't have a variable in them. Now, a linear expression is quite simply an expression where all variables in the expression have an exponent of 1 on them. This expression up here, 3 times, so 3 times, oops, I meant to go to green there. Pins green. So the expression up there, 3 times the quantity 5x minus 9 is a linear expression because the only place the variable appears, the power of the variable, the exponent is 1. This expression up here, everywhere the variable appears, the power is 1. So this is also a linear expression. So basically, the reason that these are called linear equations is because the expressions that are set equal to each other are linear expressions. Now, if a linear expression is set equal to a constant, the equation would still be a linear equation. Like, for example, if I had the equation, I'll go back to black for a second real quick. The equation, this very simple equation, x plus 1 equals 4. Because it has a linear expression in it, it's still a linear equation. So you could say a linear equation is an equation where everywhere the variable appears, the power on the variable, the exponent, is 1. And just as a foreshadowing of something toward that we'll dabble with at the end of the course, when you get to expressions that have exponents of 1 and 2 in them, you call those quadratic expressions. And then there will be cubic expressions beyond that. But the focus here is linear. Why is it linear? Because everywhere the variable appears, the power on the exponent on the variable is 1.